Okay, this warm-up is coming kind of out of nowhere. Well, I mean, it connects to what we've been doing, but we're going to do this warm-up and then we're going to move on, because this really is something that you can kind of get just through logic. And so here we have 5 to the power of x equals 5 to the power of 3, and obviously we want to solve for x. Well, let's think about this. 5 to the power of something has to equal, well, what is 5 to the power of 3? That's 125. So 5 to the power of x has to equal 125. Well, now what are we going to plug in there? 5 to the power of what equals 125? 5 to the power of 3 equals 125. Well, now let's take it back to where we were. We had 5 to the power of 3 equals 5 to the power of 3. So what does x have to be? X has to be 3 for this to be a true statement, right? So rather than going through this whole mess, which I may have confused some of you with, let's just deal with it this way. If the bases are the same, we have to have the bases the same, then the exponents must equal the same. So we can just say x equals 3. Ha! Hey, we have our solution. Okay, how about this one? Bases are the same. Actually, if you haven't already, why don't you pause and try this one on your own, because it is a warm-up. Keep going in this order. That one, that one, that one, that one, that one. All right. So, since the bases are the same, we can just set the exponents equal, right? So we have 1 minus x equals 4, and now we can just solve for x. Add 1 to both sides, divide both sides by -1, or multiply by -1, x equals -3. And if you plug -3 in to this, you'll see that it's true. 10 to the power of 1 minus -3, that's 10 to the power of 4, equals 10 to the power of 4. Magic. All right, 3 to the power of x equals 9. Our bases aren't the same. So the first thing we need to do is figure out how we can get the bases the same, which means we have 3 to the power of x equals 3 squared. And now we can just ignore our bases, just look at our exponents. That means x must equal 2, and we're done. Easy, right? Man, after all that hard stuff, nice to have something easy. All right, 3 to the power of 2x minus 1 equals 27. Once again, the bases are not the same, so we have to kind of logic our way through this. 27, that equals 3 to the power of 3. Okay, so 3 to the power of 2x minus 1 equals 3 to the power of 3. Now we can ignore the bases, and we have 2x minus 1 equals 3. That's this exponential 3, right? That's the exponent, not the base. And now we can just solve for x. Add 1 to both sides, divide both sides by 2, we get our solution. All right, we're getting a little trickier. We're dividing this time. So when we're figuring out, trying to get to the same base, we've got to deal with a negative exponent here. Okay, so let's figure this out step by step. So first, I'm just going to say this is 1 over 4 to the power of something. What is that going to be to get me 64? Left side stays the same. Well, that's 1 over 4 to the power of 3, because 4 to the power of 3 is 64, right? With me so far? Okay, now I need to get this up to the numerator. Well, how can I do that? I can turn my exponent negative. So left side stays the same. Right side becomes 4 to the power of -3, right? Because these two things are equal. I'm just doing some math. Great, now we have the bases the same and we can solve. X plus 1 equals -3. Add 1 to both sides. And we get x equals -4. I would recommend, with a difficult one like this, plugging this in. 4 to the power of -4 plus 1. That's 4 to the power of -3. Do the math, make sure that it equals that. Trust me, it does. All right, 2x equals -4. So we got to turn this so that we get the same base. 2 to the power of what is going to give me -4? Nothing. There's nothing I can put there, right? So there's no possible x that's going to fit and make this equation true. So that is no solution. Okay, so don't be scared of these when you see these. You can figure them out with logic. Just trust yourself, work through them. You got it.